ahead and get started on the 1.8 lecture. Okay, so like I said, that is absolute values. So the definition of an absolute value is if we have the absolute value of A, that is just the distance from 0 to A. So you could have negative A or A, right? And its distance to 0 is the same, right? Okay, so that makes sense, right? Basically, if we think about it on a number line, we have 0, we have negative A, and A. This distance, right, is the same as this distance. Because we don't care about negative or positive, we just care about the space measurement, right? So this is A units from A to 0, and again, A units from 0 to A. Okay? Does that make sense? Okay, so if we want to solve one, right? So if we want to solve the absolute value of x equals 7, what that means is figure out what values x could be, right? So what you do here is you say x equals the positive or x equals the negative, okay? Now, because all we're saying is, oh, well, the distance that this has, right, is 7. So that just means it could be, the inside could equal negative 7 or positive 7. It's just going back to this negative A or A, okay? Now, the inside doesn't have to just be x. It could be some quantity, right? It's just the inside has to equal the positive or the negative, okay? But what would happen if we didn't have an equal sign, but we had an inequality instead, right? So what if instead of x, the absolute value of x equals 7, we had the absolute value of x is less than, right? Yeah, less than 7. So what happens there, right? When we do the positive, it still just stays the same. X is less than 7. But when we do the negative version, it's almost like we're dividing or multiplying by a negative number, right? Because we're saying, well, the inside, this side, right, could be the negative A or the positive A, but we're putting it on the other side. So we have to say or x and flip the sign, so greater than negative 7. Okay? So when we have an inequality and we're doing the negative, just remember to flip. Okay? That's the big point there on that one. Any questions so far? No? We're good? Okay. So let's write down some of the properties here. So when we look at this, the first kind of big one is, and then the first part of it, is if we have that C is greater than or equal to 0, right? So this is just talking about with inequalities, and then connecting it to the absolute value, okay? So if we have C is greater than or equal to 0, and then our kind of absolute value, we have some stuff in it, okay? It doesn't matter what that stuff is, but it's stuff. If we have it equal to C, okay? So this is just being equal to C, or being equal to a 0 or positive number. Okay, does that make sense? No? Okay, so we're just saying we have an absolute value and we have it equal to either 0 or positive number. We don't care what it is, just not negative, basically, because negative means something else. Okay? Yes? Right? Okay, just a setup so far. So what that tells us is that stuff on the inside, okay, either equals C or equals negative C. Okay, that's exactly what we did here. We said, okay, we have some stuff equaling a positive number, right? So that falls within this first property, and we set it equal to the number or the negative of the number. Okay? But what if we have C being negative, right? So if C is a negative number and we have it the same setup of the absolute value of some stuff and it equals C. So now we have an absolute value equaling a negative number. Remember, the absolute value is saying the distance of my insides is equaling this value. Can a distance equal a negative number? No, right? We can have kind of movement being a negative, right? If I go backwards, I'm moving negatively. But if I'm just talking about the space, right, in between something and like a measurement, we don't talk about measurements being negative, right? So this doesn't work. We can't have an absolute value equaling negative number, okay? So this means that this is a no solution. So just to kind of, right, if you have an absolute value of like 3x plus 5 equals negative 2, this means no solution. Okay, just to give you a little example. It really doesn't matter what's on the inside though. It just matters that it equals a negative number. Okay? Alright, so that's kind of the first big property. So we have absolute values equaling something. Okay? So the second property is, again, we're going to start out the same way, that if C is a positive or 0 number, non-negative. Question?
Yeah, I would go forward and move forward.
This one would be? I'm sorry? This part here? No. This, that just means, like, so this is the answer. The next step, yeah, sorry. It's just a shorthand that I use. Yeah. Okay, so if we have a non-negative, right? But this time we're not going to have an equals. We're going to have a less than symbol. Okay? So we have a non-negative that we're less than. Okay? So that means that we can kind of put it in the middle. Okay, I'll show you what I mean by that. So what we can do then is we have negative C is less than the stuff, less than C. Okay? So if you have it where basically what you're saying is, right, the stuff is somewhere between 0 and C, right? It has to be within that value because remember, it can't be negative, right? So it's somewhere in between then negative C and C when you take away the absolute values. You're bounding it, okay? When we do examples, these will make more sense, I promise, okay? But this is just so that you have them to kind of reference and think about as you're going through, okay? But once you actually practice them and do them, you won't necessarily have to go back and reference these. You'll just kind of see how they work, okay? If these don't help you to think about it this way, don't worry about it. We'll talk about how to think about them without looking at these as we do examples, okay? So we'll kind of have multiple ways of thinking about them. Okay, so the second part of this is if we have C being negative, and so same setup, we have the stuff is less than C. Can an absolute value be less than a negative number? No, because it can't equal a negative number, right? So how could it be less than a negative number? So this is also no solution. Okay? So far, being equal to or less than a negative, it's no good. Already, just throw it out. You don't have to go anywhere with it. Those two, remember and recognize them. Okay? Now, the next property. So we've done equals, we've done less than, now we're going to do greater than. So, started out the same way. C is greater than or equal to 0, so we have positive, we have stuff, and we have it greater than that number. Okay? What that means is you have the stuff being greater than C, or you have the stuff being less than negative C. So if we think about this on a number line, okay, we'll see why we can't put these together. We have negative C and C. Our stuff is bigger than, and our stuff is less than. Okay? Oops, I just realized I need to move. Okay, so we see that these are in two pieces. That's why we have to have them separated. We can't put them together like this one. Okay? This, it worked because it was bigger than negative and less than the positive. Okay? This one we have bigger than positive and less than negative. This is okay still. All right? Still works. Okay, so now let's talk about the other option, right? If C is negative and our stuff is greater than C, can an absolute value be bigger than a negative number? Always, right? So that means this is always true. And your interval is negative infinity to infinity. So you kind of have a few that you should recognize so that you don't necessarily have to do any work, right? The ones you should recognize, I'll even kind of star them as super important, is this one, right? So C can't equal a negative number, and C, right, can't be less than a negative number, and then this one. So all the ones having to do with a negative number, basically, if your absolute value ends up being something with a negative on the other side, it's special, right? It either can't equal it, can't be less than it, or is always bigger than it. Does that make sense? The other parts of it, I really could care less if you remember them, because we'll have other ways of figuring it out, okay? The B's, dealing with the negative numbers, those are the important parts. Just for your sake, so you don't have to spend time on those problems, it would be good to remember them. Okay? Questions? Yes? God, no. Not this one. I'm just teaching it the night before. I would never do that to you, kind of thing. And then also, we wouldn't ever like have properties kind of things on there. So this is just for if any of you are, like to see them written out like this. There might be a few of you, I don't know. And then just to show you the kind of overall cases of those starred ones of, remember these, okay? Let's do some examples. Okay, so if we have the absolute value of 2x minus 3 equals negative 4. Can we do this? No, it can't equal a negative number. So already, this is just no solution. What about if it was equal to 4? Let's actually do one, right? So if we said negative 4, can't do it. It's no solution would be our answer, and we're just done. But let's do it out if it equals positive 4. What do? The first step, our absolute value is on its own. Good, okay. Next step, get rid of the absolute value by doing the positive and then the negative version, okay? So we have 2x minus 3 equals 4, or we have 2x minus 3 equals negative 4, okay? This is always how you get rid of the absolute value signs. You do the positive and the negative version, okay? Meaning by that, you do the same sign and the opposite sign, okay? Because remember, not on an equals at least, but there is one case where we have a negative being okay to start with. But we really don't have to solve that one because it's just everything is our answer, right? So basically we have the positive to the negative.
That's our answer.
Not yet, right? We want to solve for x. Okay? We're good to this point? Okay. So now solve for x. We add the 3, so we get 2x is equal to 7, or x is equal to 7 halves. Same on this side. Add the 3. 2x is equal to negative 1. Divide by 2. So x is equal to negative 1 half. Okay? So, those are just our answers. When it's equals, you like it, we just get 2 answers, we go with it. No, we don't. We have to check. Okay? Just to make sure, plug them in. We have the 2, it goes away, no fractions from the very first step, okay? So we have the absolute value of 2 times 7 halves minus 3. Well, 2 times 7 halves is 7, right? 7 minus 3 is 4. The absolute value of 4 is 4. We're good, right? To this one, not to that one, remember. What about on this one? We have 2 times negative 1 half minus 3. 2 times negative 1 half is negative 1. Negative 1 minus 3 is negative 4. The absolute value of a negative number is the positive, right? That's what an absolute value does. It just gets rid of the sign because we're just talking about a distance. So it's also good because it equals our 4. Okay? Just a quick, easy step just to make sure that you're fully correct and you'll get full points. Okay? Okay, so next is if we have the absolute value of 12x minus 2 plus 5 equals 9. So, remember what I said to do first. Get the absolute value by itself, right? So we subtract the 5. So we get 12x minus 2 inside the absolute value still equals subtract, so equals 4. Okay, now we do it again, right? The positive version or the negative version. Because this is a positive number, right? And then we solve. So we add the 2, so 12x is equal to 6, and divide by 12, so x is equal to 1/2. Then on this side, do the same thing, add the 2, so 12x is equal to -2, divide by 12, we get x is equal to -1/6. That's it, right? Again, we should check, but we'll just move on from here. Okay? Everybody good if I erase the properties? Okay, so then let's do the absolute value of 2x plus 1 is less than 5. Okay, can we have an absolute value being less than a positive number? Yes. It's only when they're negative that we have to think about it, right? This, we can just go for it. So, if we're not sure what to do with it, we can just separate them, right? Technically, this is the one where it's bounded. Doesn't matter. Let's just do it separate. So we have 2x plus 1 is less than 5. That's the positive version, right? We didn't do anything, so we don't flip. Or we have 2x plus 1 is greater than -5. Because we changed the sign, we flip, right? Because it's like we multiplied or divided by a negative. Okay? And then just go from there. Solve just like normal. So subtract the 1, we get 2x is less than 4, and x is less than 2. Okay? Then we have 2x is greater than -6, or x is greater than -3. Now, put them on a number line, right? Let's do them separate even if we want to. Okay, so we have -3 and 2. So, we have what types of circles? Open. And then this is less than, this is greater than, right? So technically it'd be like this and like this. But we don't know if it's kind of what sections maybe to think about, right? We think probably it's the middle part, but there's a really easy way to check, okay? Basically, let me start that over again. How I want you to think about it is get to this point, write down your numbers with whatever kind of circles, okay? Then think about the sections. We have to check this section, and this section. Just pick a number in those sections and plug it in, okay? What's something less than -3? -4. Pick something easy. Plug it into the very original, okay? So can x equal -4? We plug it in, we get the absolute value of 2 times -4 plus 1. Well, 2 times -4 is -8, plus 1 is -7, right? So we have the absolute value of -7. That would be 7. Is that less than 5? No. This section doesn't work. Let's try the next one. In between -3 and 2. 0. We love it. Okay. So can x equal 0? Well, we have 2 times 0 plus 1 and the absolute value. So that's 0 plus 1 is 1. The absolute value of 1 less than 5. Is that true? Yes. Okay, that section works. Okay, you see kind of how we're doing this? So now for the third section, because you definitely want to finish it fully, something bigger than 2. 3. Pick little numbers, pick easy ones. Like we picked 0, you could pick 1, right? Pick the smallest you can. Integers, definitely go with integers, right? So can x equal 3? Well, again, 2 times 3 plus 1, that's 2 times 3 is 6, plus 1 is 7. The absolute value is 7, less than 5. No, doesn't work. So only the middle section works. What's our interval then? -3 less than x less than 2. That's one way of writing it, right? That's in inequality notation. What about in question? Okay, what about in interval notation?
-3, 2 with parentheses.
Yes, -3, 2 with parentheses because they're both open circles. And the number line would look like -3, 2 open circles and connect them, right? Question.
Why is the first section wrong?
Because when we plugged in -4, we got a false statement, right? The absolute value of -7 would be 7. 7 is not less than 5. So because of that, that's a false statement, so that section doesn't work. Any number that you picked here would be false, basically. Okay? Okay, so that's why kind of this can work a little bit better sometimes than just remembering those properties. Yeah, it can take another minute, right? But again, it's just less to memorize, which I always like. Okay? All right. Let's do another. So we have the absolute value of 7x minus 2 is greater than or equal to 8. Okay, again, let's not worry about what it looks like exactly, other than, is this part possible? Can an absolute value be greater than or equal to a positive number? Sure, of course. Okay, so we have the absolute value isolated, right? It's all by itself. So then let's do the positive and the negative version, right? So we have 7x minus 2 is greater than or equal to 8. Or we have 7x minus 2, we're doing the negative, so we flip it. So it's less than or equal to, right? And then solve, okay? So on this one, we add the 2, so we get 7x greater than or equal to 10, divide by 7. So x is greater than or equal to 10 sevenths. Then we do the other one, add 2, 7x is less than or equal to -6, divide by 7. X is less than or equal to -6 sevenths. Okay? Alright, let's do the number line again. So we have -6 sevenths, and we have 10 sevenths. Approximately, think about those numbers, right? When we want to do the sections. It doesn't matter exactly what they are. If we want to choose something here, think, okay, that's not quite -1, right? You can choose -1 then for this part. Or to be safe, right, if you're not comfortable with fractions as much, just pick -2 or something bigger, right? It doesn't matter, that's the point. You could pick -100. It really doesn't matter, okay? As long as it falls within this section. You don't want to accidentally pick something over here. So, what do we want to pick? -1, okay? can x equal -1? Remember, all the way back to the beginning. So the absolute value of 7 times -1 minus 2. So that's 7 times -1, -7, minus 2 is -9. The absolute value of -9 is 9. Is 9 greater than or equal to 8? Yes, right? So that means this works. Then what about here? What's a good number to choose here? What? 0. So x equals 0. Does that work? 7 times 0 minus 2, absolute value. That's 0 minus 2, that's minus 2. That would be 2 greater than or equal to 8. That's not a true statement, right? 2 is not bigger than or equal to 8. So the middle doesn't work. What about bigger? 2. Yep. Because 10/7 is bigger than 1, so we can't choose 1. So we have 7 times 2 minus 2. So that would be 14 minus 2, or 12. The absolute value of 12 is 12. Is 12 bigger than or equal to 8? Yes. That section works. So how do we write out these answers? So, well,
I'm sorry.
that's okay.
Do we want them all facing the same way? Let me change it this time.
What do you mean?
I'm saying, like, the greater or less than signs, you want them all facing the same way? Or,
No,
so
we
you would-
want the x's to be on those sides, the left side.
you want-
We want to be able to say like x is something to a number, right? Either greater than, less than, whatever, to a number. So writing it this way is just
Okay,
fine.
so it would be, have it written down, I'm sorry.
That's okay.
-6/7 first, and then it'd be Weston, no, I'm sorry, I have 10/7 first.
We actually don't want to write it as, we can't write it as one thing, right? Because, see how our check marks are separated? So that means it has to be 2 separate pieces, kind of thing. Okay? Question?
Yeah, I'm really confused.
That's okay. What
On
part?
the right side.
Yes.
So I know you flipped the sign.
Whenever
But
we do
how-
with the negative, yeah.
Why'd you flip it again down there?
What do you mean?
For the answer.
I'm not flipping it because I'm not working on this one. I'm always going back to the original when I plug in. This part is just to give me these numbers, realistically. Okay? These all go back to here. Yeah.
Miss, what is this number serve?
I'm sorry?
Like, what is this number serve? What are we aiming to do with it?
We're trying to figure out what section of the number line kind of thing works for this original problem.
Yeah, so is that going to be like the answer to a question? Yeah?
So like this one, solve would be the short and simple directions kind of thing, solve for x. So then x isn't going to equal, right? But it equals an interval kind of thing. So those are generally the answers that we'll go for. How would we write these intervals out? Yeah.
10/7 with a second, infinity.
That would be one of them. So we have 10/7, comma, infinity with a parenthesis. What about the other section? Negative infinity, comma, -6/7 with a bracket. Okay. If we want to write this out all as one thing, right? We always start with the smallest number, so that would be the negative infinity. And then, because it's in 2 pieces, we don't put a comma, we put a union, right? And then the 10/7 to infinity. See how we literally just pretty much wrote the number line? Okay? Does that make sense? Yeah.
Why couldn't you just use like the arrows instead of like plugging a number in?
You can, but this is in case you mess it up, basically. Or if you're not comfortable with your kind of inequalities, right? This way always works, kind of thing. So it's a fail-safe, but if you recognize that the arrows work and you get it, kind of thing, go with it.
Okay.
Yeah. You preceded what I was going to say. There we go. I lost the word I was going to say too. So, other questions? Yes. Why is the U upside down? When is it? Never. Not on these. When you're writing out intervals, we always use union, because it's always saying this part or this part, right? X could fall in either, kind of thing. Okay? Yeah. So whenever we use interval notation, we do not use intersection. Okay? Questions on either of these last two? Because these are the ones that you kind of had to think about a little bit, right? Okay. So how this is different from when we were talking about just inequalities, right, is because when we wrote these, we kind of think about them as separate pieces, right? But if you, like we said, follow the arrows, the inequality signs, we would get from here to here and then here to here. But it's an or, so it kind of makes it seem almost like it should be the whole thing, right? But it won't be, okay? So that's the only part that you have to be careful on with these. Technically that one is an and. But yeah, I'm seeing that I'm probably confusing you, so just forget what I just said in the last like 2 minutes. Okay? Okay. So this is pretty much 1.8, okay? Because we have the test tomorrow, I'll do a little refresher on 1.8 on Thursday, okay? Just a couple problems so that we remember it after not really probably doing it for a couple days with focusing on the test tomorrow. So it, what? I lecture Thursday. Today's Tuesday. That's what I was saying. Next lecture. Yes. Yes. I got what you're saying. Yes. Okay. So at this point, we'll stop with the 1.8 lecture, okay, and move on to talking back through all the topics on the test.